Hi, everyone, and welcome back to a new episode of the Information Bottleneck podcast, the podcast that squeeze out only the relevant information. Hey, Ellen,
Hi, Ravid. Nice to see you again.
nice to see you. So today we are going to talk about very hot topic, AI coding. Um, we will have a lot of things to say and a lot of different perspectives that we want to look on it. But let's start from some news of the recent week. Um, I don't know if you know, but OpenAI just published a new paper that called "Why Language Models Hallucinate," and I think so. Really briefly, the paper claimed that hallucinations are a major, let's say, fundamental part of LLMs because of the training. Because when you train these models, you don't give them basically the option to say, I don't know, or I'm not sure about what is the right answer. So the best possible way to the option to that you give the models is just to guess, and you are not punish them on wrong guess. They can only have some benefit from it, and they basically say that you need to shift or we need to shift our benchmarks and our attention to take it into account and not to look only on accuracy but also on other metrics that are important and can say the model or like can benefit the model can benefit from saying I don't know. So my opinion about this paper is that like basically they're right, but this is not new. And I think we all know that the hallucination or like how to change or adjust models to make some uncertainty or like before we call it calibration, how to make models to be more calibrated. Uh, it's a very long topic that people are talking about it for decades. And I think this is not new in many fields, almost as neural networks are existing. And I think the problem is that, of course, like, this is not a paper for research. It's not a research paper, right? It's just, I don't know, maybe a PR paper if you want. And I think I feel a bit uncomfortable because like we treat it as research paper and like we say, oh, but this is like, let's see how we can evaluate this paper, but it's not. And they're just using something that they can promote and they can use and can say, yeah, we publish papers and we are trying to attack very important problem with LLMs.
Yeah, and I'll start on this paper by pointing out that the whole idea of, but from the foundation model labs of not having to go through the standard peer review process submitting to top AI conferences like a NeurIPS or ACL track conferences or similar is almost in a way kind of trying to take power away from researchers in those communities, for one. For two, it's being done because they want to avoid peer review scrutiny and any of the time commitments associated with it. And finally, because the reality is this thing's going to get cited 100,000 times, like all the others. Or, well, not always. Some of the more niche stuff or things that are just outright wrong or maybe incremental don't get huge numbers of citations. I'll comment on the paper itself. And mind you, I've read most of it. The discussion of how post-training messes up calibration is very good, like calibration specifically of the log probabilities of the model's responses. In fact, the idea that models are reasonably calibrated when they're pre-trained at that scale is fascinating in its own right, because smaller quality models, I don't see them calibrated that well. even the pre-trained like non RL, post-trained models. But I tend to think, okay, post-training being really messing with your log probs, it doesn't, in my mind, come to like as an answer that, oh, if we allow other, or I don't know, in this case, basically, like, if we allow some kind of notion of this information's not here, I still don't think this solves the calibration problem. And furthermore, I think that the entire body of sampling research, which I think we did our first episode on, that I also claim that OpenAI and others tend to abjectly and structurally ignore, right, would give you more of an understanding of why hallucinations happen. I mean, I could be wrong. Like, it could be that they totally do eliminate this in the training phase through like a change in loss function. And I have seen at least a little bit of work that shows like you can improve diversity past what temperature can give you through changes in loss functions during training. But I'm really of the belief that the people who look at log probs all day, and also the geometry of loss surfaces and of latent spaces, are probably the ones who have more of a clear understanding of why does hallucination actually happen. So yeah, I'm quite critical of this paper. More, not even the paper itself, but the popular takeaway that people are having. I'm very critical of that. Right now, similarly to how I was very critical of the popular takeaway to most of the scaling laws papers, where I think most people misread them.
Yeah, I agree. I agree, and I think that, like, at the end we need to separate. Like, that's fine that like they will not publish. The big labs will not publish any papers about their secret sauce, how to train this model, and what exactly to do. But when they try to do it, or like they want to do it, like they need to do it properly, and we need to pass it through the peer review process and to actually make a paper about it. Like, it's not like you can make a blog post if you want, and that's fine, but you can get both, right? You can get the benefits of making a paper, and to say that you have papers, and at the same time to make such papers. Okay. What do you say about Anthropic that needs to pay the authors the subtle lawsuit for $1.5 billion that they took books and used them to train their AI chatbots?
So I'm a wild-eyed radical when it comes to copyright and intellectual property law. I have to be careful, especially because I'm working for ThoughtWorks, and for those who know about a person named Aaron Swartz, that was the company Aaron Swartz was working for. Aaron Swartz, for those who don't know, was founder, co-founder of Reddit, and co-creator of RSS and a bunch of other technologies, who believes, among other things, that information should be free, and attempted to liberate the paid-walled millions of scientific articles on JSTOR to the public around, I think it was 2011, and got caught doing so because he'd done so in a closet in MIT, and got the book thrown at him, and he tragically commits suicide. It's a very sad story, but I look at him as a bit of a martyr. So in the sense of, so I should also say one other thing before I give my actual opinion. I've looked a little tiny bit at the details of this case, not enough to really understand it. But my core understanding is that they never trained on this data set. This was more for the purpose of circumventing the need to, what do they call it? So the idea was, oh, well, we actually can buy the book, and it's apparently currently legal if you scan the book you bought to train that way. What isn't legal, and what they did, was to circumvent the scanning requirement, because that's physically hard and annoying, by just pirating the book and digitally. And that's what got them into trouble. So at least that's how the legal framing is. I mean, I think that this might be some real creative lawyer stuff for more slightly nefarious use. I don't know. But what I would say on this is, if you think that it's unjust to be training on stuff without permission in general, right? Which I think increasing amounts of people who previously would have agreed with my copyright abolitionism are now like, oh, hell no, the moment they've realized that, intellectual property is being kind of copied without their consent, right? I think that you should be livid that this was settled because, among other things, this also means that there's no precedent set. So it's basically like kicking the can. It's for like effectively very little money. I don't even think it was a class, so I don't even think there's like the ability for every other rights holder to join in. So this was, in my opinion, a strong win for Anthropic. And furthermore, I cite the current AI moment as probably around where like the entire political system in the US has completely gone off kilter, where so-called conservatives who I would have never imagined would take opinions that the EFF, right, Electronic Frontier Foundation might have, which is to say, hey, let's allow AI training on stuff you didn't get like consent for, because information wants to be free. I'm sure Trump is basically taking that opinion on the grounds of, wow, the US is really dominant in this technology, right? But like that the RIAA and MPAA, I'm sorry, they were Republicans in the 2000s when they were suing grandma for trillions of dollars over pirating from Napster. So I'm probably rambling, but there's a lot to say here. What I would mainly say is I think it's not just that Anthropic has to pay a penny, but 1.5 billion and the way that this panned out was a win for them. So
Yeah, I agree. I think like it may be that at some point like it will be cheaper for them to just buy all the the book publishers and things like that. But I think it also raises a good question about what does it mean to train a model? Like what are the secret sauce of training a model, right? Is it the data? Like do you need the best data in order to make it? Does it matter? Like, what if they will not have this kind of data? Can they generate it by themselves? Can they use, I don't know, other models to do it? Like, I think it raises a lot of good questions that now you need to answer these questions in order to quantify how much the data worth, right? It's also related to the thing that we talked last week about synthetic data, right? If you can create synthetic data, maybe it's not maybe it doesn't worth anything.
yeah. Well, so as I was mentioning before, they had not trained on this, so there's not like a current removal from like going forward, thankfully, at least with this particular data set. But all the questions you mentioned you're completely right about. I'll point out that there's a lot of the way that you can kind of start trying to tell if something's AI generated or human generated is like that perplexity metric. And so the moment you start training on especially if you can do really large amounts of even English literature, that's going to make it just I think much higher quality at encompassing the kinds of things that humans are reading and thus interpolating is my term together in order to form their ideas with. And so I the other thing I'll just quickly note that I take this extremely radical opinion of like, sorry artists, but your information is being liberated from you, like that kind of thing. I also want to point out that it's certainly terrible for this idea of somebody to invent something and not get credit for the invention, like somebody with an AI to go and create 10,000 copies or variations and maybe even to slightly improve it just from a prompt or something and be like, no, that was mine. That's horrible. And this is one thing where cryptocurrency or even like databases, right, like proper key signing, that these principles can really be the right way to at least be like, okay, somebody created something themselves. And further, there are plenty of ways in most cases to monetize intellectual property, including personal skill, in the world of AI systems being able to selectively generate like millions of things. So I just think that we can tread a path that doesn't like destroy the livelihoods of most artists and creative types, but also doesn't force us to eliminate their contribution, which is very good from that of the demiurge here the AI systems we're building.
But it's still, like, again, it's very difficult, right? Like, you generate an image, right? An image, it's much clearer, right? Like, you generate something, or your model generates something. And so what does it mean? Like, if you have some very specific objects from other images or from other sources, or like how much, like, it will, like, you can say that this is your image or not. There are a lot of things that are very, very hard to quantify.
Yep. Yeah, and actually, I'm going to bring up two papers here that actually maybe three papers that are in our kind of list of papers to talk about today. And I'm just going to quickly basically say their names and encourage the listeners to go kind of read these, or at least the abstracts on their own. But I'll quickly summarize their importance here. The first one is titled "Extracting Memorized Pieces of Copyrighted Books from Open Weight Language Models," which is, I believe, similar arguments to this under the guise of approximate retrieval have been made and used in legal proceedings, like attempts to sue for copyright data training. And so I'm not surprised that we can, generate, in their case, whole pages of like Harry Potter, especially with sampling settings and very creatively chosen prompts. But this is why the second paper, and this is why I literally titled it with "lol," right? Because I think that it's a funny one to respond with if I were the defense attorney in this case for OpenAI. Language models may verbatim complete text they were not explicitly trained on. And what they show is that researchers can basically make a model complete like any text that they basically seed for, with even if it's never found verbatim at all in the training data, which is not that surprising when you think about it, which is the idea of, okay, well, something I generate from AI probably wasn't exactly said before somewhere, right? So the paper's more obvious than it might seem, right? But it's a fun one to kind of respond with. And I'll finish by quickly talking about one called GPT but backwards, exactly inverting language model outputs. And I'm so glad this exists, because I think I mused about it on LinkedIn a while ago, where I was like, okay, given the text, anticipate what the exact prompt would have been to recreate this exact text. And that's really cool, because if you start doing that with like really good human authored text, I claim you're going to get really wonky stuff. And potentially that might be where some of the most juicy like innovation there is in all of AI is to be like, what's the hypothetical prompt for Shakespeare to have been generated by ChatGPT perfectly? And that's going to be like alien hieroglyphics or something, right? So
Yeah. Yeah, and I think, like, this is a good place to mention that there are ways to explicitly watermark, like, the generated data, right? I think maybe the most famous, or like, is it I know, is the Tom Goldstein paper, watermark for large language models, right? That they used some kind of noise in before they generated data, right? Like, so there are a lot of ways to do it, right? Basically, you can take the generated output and you can insert some watermark inside it, right? Or look on the distribution of the word or something like that. But this is very easy to break, because you just change the output a bit and it breaks down. What they have done is they use some watermark in the input, and they insert this watermark in the input, kind of like noise to the input, and then the output looks very similar to the original output, and still you can identify that this is the output. So yeah, and there are a lot of ways to do it.
yeah, there's I think in that paper you mentioned the way is the green tokens and red tokens. So they take half of the words and they subtly upweight like I think half of the token that's in the vocab or something. And then and by the way, the more you upweight, the more detectable it is, but the more that you potentially significantly alter how your model will talk.
Yeah.
But so that red token, green token strategy is actually really cool. And like when I originally thought about that, I was like, okay, that's clever. I was like, I'm clearly not like a watermarking researcher. And there's been a ton of stuff that's come out since. It's a cat and mouse game. But I this is where I go back to my tinfoil hat. The EM dash, those weird quotes that it uses, it's not X, it's Y, all that stuff. I'm telling you, that was intentional. That had to have been intentional. There's no way that was unintentional. And I'm telling you, somebody from the NSA is at the very top of their book. I'm just telling you. I'm just telling you. Those guys have known about how good stylometry was. Those guys have known that trigrams can track somebody who thinks they're anonymous on the internet on 4chan or whatever since like 1997. So it's like some things that are old are new again, and vice versa. But yeah, watermarking works. And even humans are watermarked themselves, right? Like biometric information of various types is excellent at kind of fingerprinting them. For example, you need like 2 seconds of hearing somebody's voice to be able to do a pretty good voice clone of them, which is why I get terrified of those random phone calls from like scam numbers where there's nothing there, and I'm like, hello, and I'm like, oh, no, I can't do that.
Yeah, and it's really crazy, in the US, someone that came from Israel, like in the US, it's so weird that like you actually need to keep in secret your SSN number, right? And if someone has this number, it can do everything, and it can steal your identity and like to do whatever he wants to, right? And I'm thinking that like today it's supposed to be so easy to have multiple factors about you that will prevent it, and like all these machine learning models should do it. They should recognize your voice really good. They should recognize your face and everything. And it's crazy that it still can be.
Well, and then what they'll find is that stuff that shows that models are superhuman at reading us, right? So it's the whole thing about super persuasive because they just pick up on what you want to hear. They're going to be like reading facial emotions better than any human. Oh man. Oh. it's
fun.
about to happen. But
yeah. Okay, and now let's talk a bit about. Did you see that OpenAI says its business will spend more than $115 billion till 2029, and it's much higher than they expected before. And I think this is, first of all, it's crazy. Like, these are crazy numbers, right? And it's unbelievable that someone wants to pay so much money in order to subsidize basically the whole field, right? And I think this is something very crucial. It looks at like there are several layers, let's say, in AI, right? Like in the bottom line, the bottom layer, there are the big companies, the OpenAI, Anthropic, whatever, that have these models, and they basically spend a lot of money, and not their money, right? Someone else's money, and they subsidize the upper layers, if you want, right? The companies that generate, I don't know, application about AI and using their APIs for different enormous number of different applications. And I think it will be very interesting to understand which companies actually will survive when these subsidies will over. And at some point, I believe, correct me if I'm wrong, that all these VCs will say enough, and that they are not want to spend more money on just this a promising dream of AI, and they want to actually earn some money.
Yeah. I'll point out that this connection to like a VC appetite to invest, I will if you look at the VC investment landscape from about 2020 to 2022, maybe even 2017 to 2022, it's characterized by rapid rise of investments up to, I claim, real hysteria of late 2021 to 2022, where we saw, among other things, $700 million spent on Streamlit to be acquired by Snowflake, which was, in my opinion, the single worst deal I've ever heard, because Gradio from Hugging Face, which cost nothing for Hugging Face to acquire, still to this day is a way better Python front-end framework than Streamlit. And those kind of numbers that VCs are writing in general, after because that was the end of the ZIRP, zero interest rate era, right, in the United States. And then under the later part of the Biden administration, we see interest rates go way up, which is just to be clear, that's a sign that, hey, the economy is good now. We want economic efficiency, so that way we have some of the so-called wasteful businesses created by effectively free money through free money lending. Hopefully some of those burn out and the remaining businesses get healthier because they're forced towards profitability. So that's actually where we're at right now. The whole reason we have to pay a 7% interest on a house in the United States for a mortgage, if you're getting one right now, is because we need some economic efficiency. Note currently that Trump is desperate to lower interest rates, and he's bullying Powell, the guy, the chair of the Federal Reserve, and all of this. That he really wants an easier, money lending environment. So I claim right now that we're in the duel of possibly the height of a bubble, if there is one, hype around generative AI, and a not super great lending environment. So I claim, and in fact, I even argue that the risk of there being a true bubble in AI is lowered by high interest rates, because it forces people to either be very sure of themselves or to take giant risks. The kind of risks that I assume that people who got really rich maybe aren't taking all the time without knowing they're going to pay off. Furthermore, I claim that basically, even if parts of this were somehow close to the dot-com bubble with overinvestment, the power that somebody gets from having hundreds of thousands or millions of B200s or whatever GPUs, which is what OpenAI is probably spending all that money on, right, is data centers, because right now there is a data center mega boom happening worldwide. I claim that yeah, they're spending that because the demand's probably going to be there. We both know AI agents have exponential token demand. And even when I think about who wields the power of tomorrow, I think about, okay, well, if one person or entity now controls 10 million agents or equivalents of GPT-6 or something running on their mega data centers, I mean, I don't know, you let that loose on Reddit and tell them to do manipulation of opinion, that probably works, right? So I just think that the utility of this will pan out in the short term, and basically that OpenAI and even rich people will continue to invest in it, even if it's long-term investment, which is, Meta's whole thing too, is the risk of underinvestment is way worse than the risk of overinvestment. I think that continues to be the dynamic today. But real bubble and true loony stuff is at risk of happening if interest rates go back down anywhere near zero again. So.
Yeah, I agree. I just think that I don't think we need to worry about OpenAI, right, or Anthropic. I think again, the level of application that consume these tokens and all these models through their API in very low price, and now at some point maybe they will, I don't know, be much higher, right? All these applications will need to recalibrate their prices, and probably most of them will not have a proper model how to do it.
Yeah, and in general, the model router, we already talked about how that was a thing to try to get them, more margin back. But when they have to start earning money, that's where platform decay happens. So that's where you're going to see more things like model routers, and that's not good for users. So I for one really want to stay in a highly subsidized world.
Yeah, I think the only thing that it's for sure is that Nvidia will will have much more money
Yeah,
from the bank.
yeah, that's true. Honestly, I need to probably buy more. And yeah, unironically, it's like every time I look at that price, I'm like, God dang it! And then I look at the technical situation we're in, and I'm like, that it's a bull case. It remains a bull case for Nvidia. AMD has no chance. Huawei has no chance. I'm like, okay, it's worth it. It doesn't
Yeah,
matter what their P&E ratio is. It's worth it.
that's true. We are not recommend to buy any stuff.
Yeah, not
Uh,
formal.
yeah,
No,
exactly.
sorry.
But if you need to take one thing from this episode is look on Nvidia. Okay. Do we want to talk about AI coding and AI agents
Yes.
coding and how coding and how AI changed coding?
Well, I've
There
got
are
to
so
give
many things to say about it, right?
I have to give you credit. You're the one that messaged me maybe 8 or 9 months ago telling me about Cursor. And before that, I was still mostly writing my code by hand with like occasional chat GPT usage.
Yeah, it's from Twitter. That's all, All my information I'm getting from Twitter. It's amazing, great source of information. You should be there. Yeah, let's talk about it. Where do you want to start?
Well, okay. So first of all, I should mention that Cursor and maybe back up. A, the very it's maybe obvious to us working in AI that the first thing that AI would start doing really well is writing code, right? Software, and maybe even potentially writing AI software. As it turns out, it's not very good at that but that's too recent, but it's decent at writing code. And with that, the entire field of computer touchers, right, who tend to be pretty good at early adopting things, even that have a little bit of friction, shall we call it, for usage, we tend to be fast for that. We also, apparently, code generation was among the first places to have good user interface, user experiences created. And they're building off of these existing, what are called integrated development environments, which is basically like a software developer toolkit. Like I guess an artist has their pens and special paper and some kind of special table and all that, and they don't need it. I mean, technically somebody could probably just use a really terrible like notepad and draw with like pencils. It's harder and it probably don't do their best work. And it's a similar analogy for us in software. We like to have a true dedicated piece of software to help us write software. So that's these integrated development environments have existed for forever, really, since computers have been around. But now AI assisted editors, integrated development environments have come out, and Cursor is probably the most popular right now. There's another one called Windsurf, and probably several more, as well as extensions for nearly all of the remaining non-AI native systems. And so within really about a year ago, maybe a year and a half ago, depending on how early of an early adopter, the whole software engineering field had that revolution where I would say that the majority of practitioners, probably even at the FANG, maybe unless there's like very strict data, requirements in some cases, are writing at least their boilerplate documentation, tests even, and in many cases core significant logic, sometimes allowing agents to vibe coding, as they call it, to do the whole thing. So this has been a profound and probably the single biggest shift in coding probably in my lifetime, right, and how it's done. And so I figured, I proposed that this would be the topic of the episode today.
Yeah, I agree. I think so. I must say that I have a mixed feeling here because, from one hand, I agree with you. Like all of us are using these days, or most of us are using AI, right, in writing code, and it's great. And in some sense, coding is maybe the perfect framework for LLMs or for AI because it's right. It's closed form. Like you have specific set of rules. You can verify most of the things. You have a lot of examples. And you can get feedback, right? Like you can basically can look on the tools that the developers are using, and can get feedback. It can be offline feedback using GitHub repositories, right? And it can be even online feedback. If I'm using Cursor right now, you can take these logs, and you can use to train models. And so this is why it's almost a perfect framework. Like, it will be the best. Like, models will be the best on this use case. But at the same time, I think we all know that this is not perfect, or like it's not like in some cases it make it much worse. And vibe coding is a great example, right? And okay, so if you don't know what is a vibe coding, you're probably not in the Silicon Valley, right? So vibe coding basically is, let's make an application, or like let's write code without writing code. Just write, just tell the model what you want to build, and it will do it. You can do it iteratively. I think it was Karpati that named this term.
Yeah, on Twitter.
On Twitter, yeah. So it was quite a buzz about, let's build vibe coding applications, and let's make this. And it looks that at the end, it's really good for demos, and it's really good to very small scale, simple cases that you want to prototype something really fast, and it's quite straight off the implementation and what you want to do. But in more complicated cases, and when you actually want to build application that will not be full of bugs and security problems and things like that, you probably need much more. So I think we still need to make sure that we are making, and we are not just saying to the model what exactly we want to do, and forget from the real code. And I think when you work with these models in practice, you can see that, right, that like it's really hard. Like they're making a lot of code, they generate a lot of code, and it's really hard to understand if this is actually like an efficient code, right? Like it's really hard after it to go over it, and I don't know, to find the problems. You need to make very like a lot of unit tests, for example. And sometimes they really want to agree with, right? So if you tell them something, they will go with you even if it's not the right solution. So many cases, in many cases, many times I see that I'm writing something, I'm telling the model to write something, and then like after it, I see that there is much simpler solution, right? I have change a line instead of writing 100 lines, and it will never get it. It will never know how to simplify the code and make it more simple and better at the end. So yeah, it's I'm not sure what I'm thinking about it.
Well, I'm glad you talk about these like problems and experiences with your own workflows and usage of it, because I have so much to say here. The first one is that my own workflow and usage is in Cursor, at least. I extensively use this Command K, I think, or Control K, where I highlight a specific portion of the code I'm interested in and want edited, and then will open up the editor. And I have been influenced by so-called vibe coding, because I think the real innovation of vibe coding is the idea of talking to the computer, not the idea of being so lazy that I don't like look at the output, right? I think that I'm a lot faster and even cognitively lower load for me to, because rubber duck debugging, now it's loaded into the editor, and ChatGPT can do a great job when you just talk it out with enough detail in a lot of cases. And then, when I'm saying Command K, I'm referring to I'm only modifying usually small snippets of code at a time. I tend not to use like cursor agent mode because I find it goes too far, too deep without like workflow. If I do use it, I'm looking at every step and oftentimes modifying things or stopping and starting new chats. That's another one, is I'm very hyper vigilant around context rot. And I think the majority of people, especially vibe coders, quickly get to that point where even if the model could have reasoned about their code base, half of the context was already used up with all the previous discussion, and ruins the potential they could have gotten from it. And then finally, you have to be thinking about, okay, if I choose this model, like GPT-4 versus Claude, which one has the later data cutoff point for one, which one will act a particular way for another, even with like following cursor rules, like system prompts to try to kind of change it to be like, oh, always capitalize your variables, or stop doing static type checking because that wastes a bunch of tokens, even though that's pretty. Also, sometimes you're wrong about the types you think it is, that kind of thing. And related to kind of my own experiences of using it, in my opinion, well, because I can tell you that it's a crazy force multiplier when, in the same way that autocomplete is. And indeed, real autocomplete is still one of the things that you get in these AI editors, where, you're typing something and then it's like it sees what you're about to type and you just press tab and then it does it. I think that autocomplete is the single biggest force multiplier, just from boilerplate being much easier to complete. And then afterwards, the Command K kind of, I guess what I'm trying to get at is the more human intentionality that goes into using AI systems, the more likely you are to be happy with the outputs. And so I come at these systems from a wow, you're magically powerful, and I need to put a lot of my humanness into him. And I tend to be pretty happy with the outputs as a result of having managed my own expectations. But I'll quickly go over a few papers that I think are relevant for this topic. I think we'll dissect maybe one or two of these a little more, but I'm just going to quickly go through them because I think they're interesting. One of them is titled "Kernel Bench: Can LLMs write efficient GPU kernels?" And then I answer with in parentheses here, no, because that was kind of the result of the paper, which shows that AI systems struggle with like parallel, GPU based programming. It's really hard programming, very few examples on the internet. You probably objectively need a high IQ to be good at it, kind of stuff. And yeah, AI systems are lousy and pathetic. So if you're in the GPU programming space, your job is probably safe for a while, right? Similarly,
But do you think that this is Wait, Alan, but do you think that this is like because we don't have enough examples, or like this is something, I don't know, deeper in the GPU's kernels or whatever, that actually it's harder to I don't know, to find the right solution? Or maybe like we just in other cases, right? Like there is all this evaluation crisis, right? That we don't have enough or good enough benchmarks in order to evaluate, even for code, right? We are taking in the SW bench, we are taking some GitHub repositories and look on these repositories and see if we can solve these issues. But it's not like there are a lot of problems with the data contamination and a lot of problems that we don't know how to evaluate it. So do you think this is just a case that we have good evaluation, that the model just they are not good enough, or this is something more specific?
It's definitely hard to say. I will point out that the authors, by proposing a benchmark, are hoping to, at least if it's benchmark related, they're hoping to have done a little something to help that part of it. I also note that, verifiable rewards are where we get so much of the value from post-training, and code, as we've mentioned, has verifiable or can have verifiable rewards, logs. Did the code execute correctly or not, being probably the most obvious one. I tend to think that GPU coding in general is just extremely difficult. even to the point where knowledge about how it was done on H100s or B200s might not make that much, like might not do that much to help you on Rubin, like the next version. I would love to be proven wrong on this, but I tend to think that really difficult non-sequential kind of paradigms are difficult. Similarly, I swear I saw something that basically showed that like asynchronous code is really difficult for AI models. And even, if it wasn't difficult for models, then we would see it be really easy for ChatGPT to generate highly responsive websites, right? A lot, AI people like to pretend like JavaScript might be some easy. No, JavaScript is like this horrible monster of a language, primarily because to be even a halfway decent JavaScript dev, you have to get really good at asynchronous programming, promises, callbacks, all this kind of stuff, which is something the vast majority of Python programmers don't know how to do. It's like manual versus automatic transmission in the like difference in how you think about things. And yeah, Python has yield and all this, but I the fact remains that I tend to think that like similar to like functional programming, like exotic kind of things that tend to be hard for humans in this realm, I think are much harder for AI systems. But I'm not super confident on this either. Like it could just be all evaluation problems. I think that like the idea of universal function approximation, and there's a whole lot of things with many variables and issues like this that we thought wouldn't be solvable that totally did get solved. So I'm willing to give it the benefit of the doubt.
Yeah, I agree. Like I agree that it will be much harder because you have some kind of like you need to go into the future, right? Like asynchronous code, you basically need to simulate it, right? And you need to go deeper and deeper to the future. So, and it looks that these current models are quite bad in that. But from other hand, like we were so wrong in the all of us, right? Like we never expected that the models will be so good in so many fields. So
Yeah.
okay, you have more papers that you want to share?
Yeah. So kind of related to the GPU kernel question was Backbench, another benchmark. Can LLMs generate correct and secure backends? And their answer was also no, right? Like lots of security vulnerabilities and similar types of issues. And that's, I think humans write stuff with a lot of security vulnerabilities too, but I think that the kinds of code that's most highly represented on the internet and possibly in the training data probably has a lot of security vulnerabilities. And then
Yeah, I just want to say here that I agree. I think like security issues are a huge problem then, because like when someone write a code, right, like you can expect or you have good estimation what kind of errors they can do, right? It's similar to, I don't know, a travel agent, right? There is a lot of um, startups that are trying to make travel agents right now, and one of the big issues is insurance, right? That like if you have a human travel agent, you know that they have some insurance that if they are writing your name incorrectly, they can change it after, right? They can change the ticket, right? But what if the model just write totally different name in some totally random I don't know, date and some destination, random destination, and it's much harder to understand or like to estimate what are the errors that the model can do. So in this case, of course, you can eliminate it and you can just try to make very specific options that the LLM can fill out the form. But this is very hard to understand or to estimate what kind of errors the LLM will do compared to humans. And I think it's also true in security. And we need let's say, we need much more guidelines in order to make sure these models will be safer.
Yeah, and it occurs just a quick kind of note on like sampling and code generation here. When I think about the ideal sampling setting for generating code, I think greedy decoding, but I even think beam search, which is the idea of basically search whole sequences down the tree and try to take that with the lowest complexity, which is analogous to the idea that many software engineers, when they're writing something, they've already kind of got an idea what the end might look like ahead of time. Just as, I think the AI systems should. They at the very minimum should not be having this like non-zero probability of sampling something way deep potentially in their log probs, like the 50th most likely continuation. That's great for creative writing, probably pretty bad for code. And similar with security, I think security vulnerabilities are probably highly tied in code to non most likely token continuations. I really love that kind of study to be done. But there's some more papers as well that I'd like to quickly cover. So we mentioned, correct and secure backends are also a problem. And then there's a final one in this theme. Can large language models understand intermediate representations in compilers? With, yet again, the answer was no. But that one's the most interesting here because when we're talking about an intermediate representation, these are things like for Python, the equivalent is an abstract syntax tree for so this would be like your bytecode or the code you get before you go to assembly. If you went from C++, there's like a intermediate representation there, and that is, in my mind, that means that AI systems struggle to simulate how a computer operates within their own latent space, which is really expected. I mean, I didn't expect like the latent space to form perfect model of a Turing complete system. Maybe that's impossible, right? But it means that humans are having a ability to get a pretty close, like, no, we don't simulate compilers, but I claim that, the great graybeards who are way better at talking to computers than humans have clearly learned a bit about what it means to be a compiler, right? And I claim that LLMs are probably behind your oh god, the people who invented like Linux and write kernels all day and all these. I think that those people get it more. And so this is what I mean. It's like the programming that we think is hard as coders is hard for the AI systems. And so I view AI systems as being real drivers of inequality, right? They're going to take the people that are already pretty good and supercharge them, and the people that aren't really good and kind of make it really hard for them to ever get to that point. Because, and this is the final paper I'll talk about, is this is like a position paper actually at ICLR titled "Humanity Faces Existential Risk from Gradual Disempowerment." And it's related to a lot of this research that shows that people that use AI systems all the time get like cognitive decline and start to reduce their own agency over their life and the things that they create. And this is disempowerment. And so these authors think that basically removing humans from the systems will lead to us ceasing to exist. So I buy this idea that we have to do something soon to kind of get things under control with humans' relationship to these systems. Especially because I've had personal experience just now with working with somebody who has vibe coded everything, and it is a complete mess of technical debt. Like, I really just want to start from scratch on that.
Yeah, I just want to mention one more paper that's called Measuring the Impact of Early 2025 AI on Experienced Open Source Developer Productivity. And it's crazy. They took very experienced developers and they asked them, they let them use developing like coding AI tools, Cursor Pro or something like that. So they took open source developers that they let them working on their own repositories, and they just split some of them. They allow them to use AI tools, and some of them not. And they ask them how much, like, they ask them what is the how much you think the AI will help you, the AI tools will help you, and they said something like 24% or something like that. And apparently that in practice it reduce their capability, or like it increased their time in 90%. Okay, they were much less efficient if they were using AI tools. Now, the crazy thing is that even after they told them that, look, like, these tools are make you much more inefficient, and like they increase their your time developing, and now they ask him, okay, so how much you think you actually improve, like how much these AI tools will help you. They still found that these AI tools help them much more than it was actually in practice. And I think we need, again, let's summarize that. I really think that these AI tools are really good in many cases, and they're good in so many things that are hard for us as humans, right? Like in code, in debugging code, in understanding code, and in writing code. But in many cases, it's like these gambling machines, right? It's like you're pressing the button, you're pushing the button, and you see the like all the bananas that are trying to be like, you need 3 bananas, right? And this is exactly like at least my feeling when I'm using some of these tools, some of these AI tools, that like, now let's press and I'll ask the model one more time that like explain it what we actually want, and let's do it again and again and again. And now every time it's almost there, but it's not there, so I need to spend more time. And I don't want to lose all the time that I already spent in explaining the model. And I but from other hand, I'm spending so much time at the end on these models. So it's we need to be careful. This is what I'm saying here.
Yeah, I agree. And I think that there's, been people that are using them in their projects for only documentation, or even just a bot that looks at all the PRs to a large project and tries to basically decide, like, score it if it's good or not. And that's like a good way to prioritize very limited project owner kind of time for committing stuff. I'll finalize by saying that based on the experience you shared, I have my own experience recently. Actually, I wrote this submission for NeurIPS about a super persuasive AI agent, and the code for that was written in a way where I wrote probably 2 examples, like agent workflows, mostly by hand. And I was able to get it all working, and then I needed to slightly modify this, where the prompts would be modified, and even the logic of how the agents were called, just slight modifications. And I was able to successfully use Cursor to basically copy and paste this alongside me talking to it and being like, okay, modify this like this, modify it like that, because I had to do that about 20 different variations, and it worked very well. I had no issues related to the AI giving me something. But I've also had the exact same experience you talk about, where I'm trying to do something I don't fully understand very well, and I'm just like sometimes bargaining, trying like the trick of, I'll pay you $10,000, or the whole the ridiculous one of like, grandma dies, or so, if you don't get this right, or all the stuff that people were testing on playing with the prompts and some of the papers. So
Yeah. Anyway, I think it looks that AI tools will not replace AI researchers soon, or like at least
yeah,
in the next year.
yeah.
That's good.
Yeah. Yeah, and it really was kind of, and still remains a bit scary. It does look like large amounts of creative industries are going to be potentially hollowed out. And I did think software would be first, and I think we're, yeah, maybe a few more years, but like chess engines are the thing where AI plus Grandmaster was not better than Grandmaster for more than like 10 years. So uh, at some
Yeah.
point, I think AI will be better than me, at least at coding.
Yeah, I agree. I think it's very interesting because let's say 5, 6 years ago, like people thought that the first fields that will disappear or like will replaced by AI will be the more, let's say, monotonic fields, right? Like I don't know, lawyers or things like that. They will do something that it's very like there are no other option. You have one, hopefully, possible solution. And it looks now with all these AI, I don't know, AI creativity and generation and things like that, is that it's the opposite, right? That like I don't know, painting and to be very creative, it's not something that it's valuable or like almost not valuable anymore. That AI can replace you, right? It can be just hallucinate all the time.
Yeah, yeah, and going back to the sampling thing, I'm very fascinated about what, like, I don't look at when I'm generating code the log probs too much, but I would love to see, because I always felt like software was artisanal, like craftsmanship, not as much engineering, where it's like, well, I could do something one way, but I could do it another way, and that other way could actually just be more aesthetically pleasing in various forms, So I'm wondering, it's like, wait a moment, do if I went with, let's say, the fourth continuation instead of the first continuation at every time step, we'll just call it, I don't know what you call that weird sampler. Um, will it generate coherent code, right? And if the answer is yes, and I think it probably is, at least for sufficiently good models, that just means, I guess, something we already knew, which is that you can write code a million different ways to get the same thing done, but there's something more fundamental at that result, I feel like. I don't know what it is, but something's there.
Okay, I think we are just in time to finish. So thank you everyone that listened to the podcast. Thank you, Alan. See you next.
Always happy to help, and we'd love for people to leave us comments or send us emails or get into contact with us and tell us what we're doing well and what we're not doing well. We only very lightly edit these podcasts. I'm like adding various classical music on at about 25% volume, and we don't know what people think we're doing well and what they think we could improve on. So we'd love to hear from you.
Yeah, about the structure, about the content, about the quality, about everything. Let us know. You can find us on Twitter, LinkedIn, email. We will happy to hear you. Thank you very much. See you next week.
Bye.